Hey, Mike from Prep Pros. I've been a full time SAT tutor for over 8 years now. I've scored perfectly on the SAT myself. I've published what I think is by far the best SAT math book out there. And although I didn't take the test in May, I had a few of my students score over 1530, including some perfect 800s on the math section. So we're going to jump straight into the explanations. But if you want some general tips and strategies and the type of structure I use to help those students get perfect scores, check out the end of the video. All right, question one. 8 data points are shown in the scatter plot. A line of best fit for the data is also shown. Which of the following is closest to the y predicted by the line of best fit? So that means for an x value of 3,700. So we're going to be looking at like 3,700, and we're looking for where it intersects the line. It's going to be right about 33 here. No other answer choice is close. All right, an object has a mass of 3,300 milligrams. What is the mass of the object in grams? Well, this is just a unit conversion question. So we're going from 3,300 milligrams. If we're converting this into grams, we're going to do it by 1g over 1,000 mg, which when we go ahead and multiply these through, we're going to get 3.3. All right, what is the y-intercept of the line graph? Just have to be careful to make sure this is actually being scaled by ones, which it is. So it's just going to be 0, 1. All right. On average, 1 square inch of human skin contains 650 sweat glands. Certain area of skin contains 1,170 sweat glands. Based on this information, which of the following is closest to the size of the area? Well, 1 square inch has 650, so we can simply do 1,170 divided by 650, which is going to be greater than 1. Therefore, we can tell that D is correct. The graph of the function t is shown where y equals t of x. Which of the following types of functions is graphed? Well, it's not linear, because linear would be you see the same slope, and it's definitely not increasing. This would be an increasing exponential, so we can see it's decreasing exponential. Which of the following dot plots, each with 9 data values, represents a data set with a median less than 70? So if we're looking for median value, we have a little trick that I always teach everyone. You take the number of items in your list, you add 1 to it, you divide by 2. That tells you where the median is. So here we're going to do 9 plus 1 over 2. It's going to give us 5. That means our fifth value is going to give us the median. So less than 70. 1, 2, 3, 4, 5. That would be 70. So 1, 2, 3, 4, 5. This one would be our median. 1, 2, 3, 4, 5. Our fifth value would be our median. That's why we can see C is correct. All right, the table gives the heights in feet of 5 peaks in the Rocky Mountains and 5 peaks in the Appalachian Mountains. What is the height in meters? So more unit conversion here of Blanca Peak. So this is in feet. So if we want to put it into meters, do 14,350 times 1, and this is, let me put my units in here so this makes sense for all you guys, feet times, we're going to do this 1 meter over 3.28 feet. So pretty simply, we're taking our 14,350, and we're dividing it by 3.28. And that's going to give us our correct answer here of B. All right, so same table, so I'm going to skip reading that stuff. For the given Appalachian mountain peaks, so we're just looking down here. The height of the highest peak is approximately what percent greater than the height of the lowest? So let's make sure these are actually in order, and they are. So this is just a classic percent thing. This is something we expect to see every single SAT. This is really just a formula. Super simple way you can remember it is new minus old, or new minus original over original. And then you'd multiply it by 100 for your percent increase or decrease you're looking for. So here, it's going to be, in your new minus old, you can also think of, like if we're thinking of the increase, it's bigger minus smaller over smaller. So this is going to be our 6,684 minus our 6,611 over our 6,611. Now let's use our calculator for this one here. This is beyond my comfort level for mental math. Then we're going to multiply that by 100. That's going to give us 1.10. So A is going to be our right answer. Back with more medians. So which statement best compares the medians to the data sets? Well, these are organized from smallest to largest, so we can just do this kind of the old school way. Let's cross them off. Smallest, biggest, next biggest. We get 2 in the middle, so we take the average of these. Well, 6 and 6, it's going to give us an average of 6. Now let's go to the next one. Smallest, biggest, next biggest, next smallest, next biggest. We're left with 6 once again, so they are going to be the same. The mass of a solution of isopropanol and water is 100 grams. The given equation represents a situation where X is our isopropanol and Y is the volume of water. If the volume of isopropanol is 70, what is the volume of water? Well, we were told that isopropanol is X, so I'm just going to go ahead and pop 70 in for X. So I'm going to do 0.79 times 70 plus 1.0y is equal to 100. And then we just get to solve this from here. So that's going to give us 55.3 plus 1y is equal to 100. Subtract this on over, and we're going to get that y is very close to 45. And we see approximate, so we don't have to be perfect. There are 435 voting members of the House of the U.S. Reps. If B voting members are in favor of a certain bill, which expression represents the percentage of voting members in favor? Well, percent, we're just looking for piece out of our total. So it's just going to be B over 435. Then we're multiplying it by 100, very similar to what we did in that prior question. These are really closely related questions to basically identify that A is right. One was increase, decrease. This is what I kind of teach and have in my math book as simple percentages. But these, once again, you should expect to see this every single time. Which of the following equations has the same solution? Well, most of these, we'll see if this works here, but most of the time with these, you can just simplify them down and find the same equation. So we divide both sides by 10. We'd get x plus 120 is equal to 12. And we do see that exact same thing, so A is going to be right, and we get to move on. The graph shows the change over time in milliseconds in a neuron's membrane potential in millivolts during an electrical brain signal known as an action potential. Which of the following times in milliseconds is membrane potential closest to negative 70 MV? Now, I know this isn't the greatest screenshot from the test, but this is our MV, so we're just going to basically draw a line here and drag it on over. And I'm going to go back with my kind of smaller stylus here, because it should be 5. Just want to try to put it here so it makes sense for you guys. So yeah, so 5 is where we're going to intersect it. So that's why D is going to be our correct answer there. All right. Given function C models the annual soybean use in China in millions of metric tons between 95 and 2014, where X is the number of years after 1995. Which graph best represents this model? Anytime we kind of see these, the first thing I always just start with is y-intercept. So both C and D, I can tell, don't give me a y-intercept of 19. A and B, I can't really tell a clear difference between. Up, over. This one's going to have way too low of a slope, but what I always teach students to do, and if you guys watch my prediction video, hopefully you got this right. This is kind of what I think of as a cheatable graph. All you have to do is pick a point on the graph. This one's a little hard because we can't see these really clearly, but it looks like we have the point 12, 70. And if we plug 12 in for X, we should get a value very close to 70 for our output. So 4.3 times 12 is 51.6 plus 19 puts us right on the dot. Anytime you get these, just pick points, plug in your X and Y values, and you can be completely confident of your right answer. Remember, C of X is the same as Y. The given function C models the annual soybean use in China in millions of metric tons between 95 and 2014. Okay, same thing. According to the model, what is the best interpretation of the 4.3? Well, this is going to be our slope. This is our y-intercept. So this would be our starting value. Each year between 1995 and 2014, China used 4.3 million metric tons of soybeans. So let's reread this because this is an interpreting lines question, so you want to be really careful to make sure you're getting all the language right. Models the annual soybean use in China in millions of metric tons between 1995 and 2014. Um, yeah, so this is wrong because each year they didn't use this amount. Each year they increased their use by that amount. Our first year, we would plug 1 in for x, so we would see that it's way bigger than that. So that's why B is our correct answer. But once again, these are kind of like if you plug values in, it's way easier to identify the right answer. Otherwise, they're really common to kind of make silly mistakes on. All right, the given function C models the total cost, sum of fixed and variable cost in dollars, of growing and harvesting X bales of hay on a certain farm. The given function R models the revenue in dollars earned from selling X bales of hay. According to the function R, how many bales of hay would have to be sold to earn 1,425? Well, this is our output of the function, so we can just rewrite this as 1,425 is equal to 4.75x, and then we're dividing by 4.75 to solve for x. That's going to give us correct answer here of B. All right, so same information. Which of the following inequalities models the number of bales of hay that must be sold to earn a profit of $10,000 or more? Profit is our revenue minus our cost. So we can say our profit is equal to our revenue, our 4.75x, minus our cost, which is our 50,000, plus 0.75x. Well, this is going to tell us that our profit is equal to, distribute this, we're going to be subtracting the 0.75x. So we'll get our profit is going to be equal to our 4x minus 50,000. And now we're saying must be sold to earn a profit 10,000 or more. So now what we're saying is this, looking at our answer choices, model the same way. Okay. So it should be A here because we're saying our $10,000 has to be less than or equal to our 4x minus 50,000. That's going to be our kind of bare minimum. Everything beyond that is going to be additional profit over 10,000. That's how we can see that A is correct. All right, which expression is equivalent to this one? So quadratic stuff here. So we have to remember we're going to have to FOIL this. So this is the same as x squared plus 4 times x squared plus 4. We'll just do this part first, then we'll bring in our second part. So this is going to give us x to the 4th plus 8x squared plus 16. And then x minus 2 times x plus 2. This is going to be equivalent to x squared minus 4. So we're going to add in an x squared and a minus 4. So this is going to give us x to the 4th plus 9x squared plus 12. And that will give us our correct answer here of D. How many solutions? This is another one that we absolutely want to make sure we have down. Really easy once you know your rules. Since our slopes are the same and our y-intercepts are different, we're going to have parallel lines that never intersect. Therefore, we're going to get 0 or no solutions. Which inequality represents all values of x for which the graph y equals h of x, so just this graph, and the xy plane is above the x-axis? Well, first thing we have to do is just solve for where the x-intercept is. And then it's going to be all values greater than that. So to solve for the x-intercept, we simply plug in 0 for y. So we'll do 0 equals 3x plus 3. So give us that negative 3 is equal to 3x. So give us that negative 1 is equal to our x-intercept. So it has to be all values greater than negative 1, because if we're thinking about a graph, it's a very poorly drawn graph. If we're thinking about a graph, once we go below the x-intercept, all of our values of y are going to be below it, or negative. All right, 21 here. The graph models the mass y in nanograms of cobalt remaining in sample after x half-lives. The half-life of this cobalt is 5.27 years. What is the mass in nanograms remaining in the sample after 10.5 years? Well, this is just going to be 2 half-lives. That's the same as 5.27 times 2. So we're just looking for the spot on the graph here. B is the only answer between 1 and 2 for our kind of mass remaining. So that's how we can see that B is right. Which quadratic has no real solutions? All right, so this is another one. I'm going to grab my calculator here. Which quadratic has no real solutions? What this really is testing you on is your discriminant rules. So this is going to give us b squared minus 4ac has to be less than 0. That's kind of our best rinse and repeat way we can look at this. This one, just graphically, no real solutions also means you don't have any x-intercepts. So I can tell that A isn't going to work because it's going to be shifted down. It's going to have two x-intercepts. This is simply going to be our standard parabola stretched and shifted over. I'm pretty sure it's going to be C here, but we're just going to check this. So this would be 3 squared minus 4 times our A value is 3 and our C value is 3. 4 times 3 times 3. This will give us 9 minus 12 times 3. This is going to give us 9 minus 36. That is indeed less than 0, so that tells me it has no real solutions. All right, for the triangle shown, which equation is not true? All right, so some of our fun trig stuff here. So sine of x is 42 over 59. That's true. This is our opposite, our hypotenuse. So that works. Sine of 90 minus x. Oh, this is their favorite trig thing. Once again, this was back on the March test I took. So 90 minus x would be up here. Well, 90 minus x would be this side length down here over 59. And that's not going to be true because that side length pretty simply is not 42. So B is going to have to be our right answer. Cosine of 90 minus x. Once again, this would be our 90 minus x angle up here. This would still be 42 over 59. And sine of 90 minus x, this is just your trig identity. That statement is always true. In 1976, there were approximately 1,000 gray wolves in northern Minnesota. The number of gray wolves in northern Minnesota was percent increase, so tons of percent. So I called quite a few of these questions. This is one that I could see a lot of students probably would have missed. Was 190% greater than in 1976. Approximately how many gray wolves were there in Minnesota in 2008? Well, if we're doing percent increases or decreases, it's always the original value times 1 plus the percent increase or decrease. 190% is the same as 1.9. So this is the same as 1,000 times 2.9, which gives us 2,900. Now, a lot of students probably incorrectly picked B. This would be okay if it said there were approximately 1,000 in northern Minnesota. The number of gray wolves in 1976, there were 1,000. The number of gray wolves in 2008, if it says was 190% of 1976, B would be your correct answer. This concept of increase, decrease shows up on every single SAT. That's kind of why I have an entire chapter dedicated to in my math book, but it's really, really important to understand because students miss it all the time. When the quadratic function f is graphed in the xy plane, its vertex is negative 2, 5. One of the x-intercepts of this graph is negative 7/3. What is the other x-intercept of this graph? Man, I was nailing a ton of stuff that showed up on this test. So for this one here, what you just want to understand in terms of your parabolas is your x-intercepts. If you take the average of the two of them, it gives you the x value of your vertex because parabolas are symmetrical from their x value of their vertex. So you can solve this by simply using your midpoint formula. Say that negative 2 is the midpoint of negative 7/3 plus, we could say x over 2. So we can cross multiply. This will give us that negative 4 is equal to negative 7/3 plus x. Let's put this into thirds. So this is the same as negative 12/3 equals negative 7/3 plus x. We can add over our 7/3. That will give us negative 5/3, which is our answer. All right, the box plots summarize data set X and data set Y. Each of the data sets consists of a total of 100 integers, which the following statements must be true. The mean of data set X is less than the mean of data set Y. We cannot tell that for a few reasons. Mainly, this box is representative of the middle 50th percentile of the values. So the majority of our values are falling in the same area. Yes, the minimum of data set X is less, but we definitely cannot be certain that the average of X is going to be less than the average of Y. Um, the reason, if you kind of missed this, that you probably missed it, is these lines in the middle of your box and whisker plot, which I'll kind of draw in to be a little bit clearer. There, those are showing you the median. So the only thing that we 100% are positive of is that the median of X is less than the median of Y. That's why B is correct here. The only way we could kind of possibly tell that the mean would be less is if we had like the entire box was down here, because then we could really like start to logically infer that. But without that, you're not going to be able to make that statement correct there. All right, for an exponential function g, the value of g of x decreases by 20% for each 1 unit increase in the value of x. If g of 2 equals 16, which of the following could define g? Well, this is our starting value. This is our increase or decrease. This is always same kind of percent concept, 1 plus or minus. Well, this is going to be the same as 1 minus 0.2, so it's going to have to be 0.8. So that gets rid of c and d for us. Now from here, we have a point, so let's just fact check these. We know if we plug 2 in for x, the output has to equal 16. So we can just go ahead and check those. So we're going to check a to start with. 2 minus 2 equals 0. Well, anything to the 0 is 1, so this is going to equal 16, because we're going to get 0.8 to the 0. We'll get our 16 times that, I'll put the parentheses where they are in the problem. So 16 times our 0.8 to the 0. This is the same as 16 times 1. So this does equal 16. That's why A is correct. If you plug 2 in here, you're going to be doing 0.8 to the 4th power. And this is going to give you a relatively small value. So we get 0.4 times 16. That gives us 6.5. This is kind of a very similar, like just plug values into some of the stuff we went through earlier. If you're given points on graph, if you're given points in equation, plug them in. It gives you the easiest way out. Micha and Rana each selected a random sample of students at their school and asked how many soft drink servings each student had consumed the previous week. Micha estimated that the mean number of soft drink servings was 7.1 with an associated margin of error of 1.2. Rana estimated that the mean number of soft drinks was 8.3 with an associated margin of error of 0.8. Assuming the margin of errors were calculated the same way, which of the following best explains why Rana obtained a smaller margin of error than Micha? This is just something you want to have memorized for the SAT. It's free points at the end of the test. Is your sample size increases, your margin of error decreases, because as you sample more and more of the population, you should be getting closer and closer to the true value. So we need a smaller margin of error to compensate by what we could have missed by. That's simply why A is your correct answer here. Has nothing to do with either of these statements. It's just bigger population, bigger sample size, smaller margin of error. Smaller sample size, you're going to get a comparatively larger margin of error. Circle in the xy plane has its center at -3, 4, and the point -2, 1 lies on the circle. Which equation represents this circle? Well, first thing here is we know our standard form of a circle is x minus h squared plus y minus k squared equals r squared. So this is first going to be x plus 3 squared plus y minus 4 squared. That's going to give us the first part. So we can go ahead, we can eliminate c, we can eliminate d. Now, simplest way, this actually is like an example problem from my book practically. To solve for these, this is such a standard question. This is kind of free points if you know what to do. -3, 4, so let's put a point over here at -3, 4. Anytime you're looking for distances on the test, the simplest thing you can do is you can go ahead and just draw a triangle. So from -3 to 4, we're moving over 1 with our x values, and we're moving down 3 with our y values. So we can simply do a squared plus b squared equals c squared, and that's going to give us the same as our r squared value. So all we actually have to do here is 3 squared plus 1 squared is going to be equal to r squared, and that's just going to give us 9 plus 1 is equal to r squared. That's going to give us that 10 is equal to r squared. Therefore, we need to have 10 here. That's going to tell us D is correct. For the quadratic function h, the table gives 3 values of x and their corresponding values of h of x. At what value of x does h reach its minimum? This is testing the exact same concept we saw a handful of questions ago. We know, as we talked about, that if you're dealing with a parabola, the midpoint of its x-intercepts gives you its vertex, which is also its minimum or maximum. So we have, this is our h of x, remember, is our y value. So we have an x-intercept of 2 and an x-intercept of 4. So we have it 2 and we have it 4. The midpoint of those two, just the average of them, is 3. So it's going to reach its minimum at 3. Certain rock band released 20 music albums from 1963 to 1970. If one of these albums is selected at random, what is the probability of selecting an album that was released in 1964? So that's just 7 out of 20, which will give us our correct answer. You could also put in 0.35. Either one of those works. 32, a company decides to sponsor an employee bowling team. The cost to form the team is $180 per team member plus a one-time $25 registration fee. What is the maximum number of team members who can join? If the company can spend $925 for the bowling team. So, okay. So first thing I would do here is I just do my 925 minus 25. That's taking away the one-time team registration fee. So we're left with 900. And then the really kind of simple way to solve this is let's just divide by 180 because that's the cost per team member. And that's just going to give us 5, and that will give us our right answer here. Just want to make sure I didn't miss anything. Yeah, so 5 will work there. Solution to the given system of equations is xy. What is the value of x? Well, always love to stack and cancel on these. If I just add these two together, I cancel out my y's. So this just gives me that 5x is equal to 18 plus 17, which is 35. Divide both sides by 5. I get that x is equal to 7. 34, for the elements in the periodic table having atomic numbers 1 through 18, the bar graph summarizes the number of elements by their number of valence electrons. How many of these elements have at most 4 valence electrons? So at most is just going to be this part of the table, these two pieces. So 6 and 4. So our answer should just be 10 here. Just want to make sure this is like so simple I'm not misinterpreting something. Yeah, okay, then I think it's just that easy. If 5 root 3x minus 2 equals 13, what is the value of 3x? Well, this is kind of, first thing we're going to do is going to add that 2 over. So we'll get 5 root 3x is equal to 15. Let's go ahead and divide both sides by 5. This will give us that root 3x is equal to 3. Now let's just go ahead and square both sides. This is going to give us that 3x is equal to 9. We're solving for 3x. Anytime you see stuff like this, put a big fat circle on the page so you don't kind of stop short or solve for x instead. But that will give us our right answer there of 9. Yep. All right. If x over y equals 8 and 2x over ty equals 160, what is the value of t? So we're going to have to do some substitution here. So x over y equals 8. Okay. So first thing I would do is I would just cross multiply. So this will give me that x equals 8y. I want to do this because I don't want to have a bunch of variables in this expression. So now I can substitute in. I'll do 2 times our 8y over ty is equal to 160. Now this will give me, I'm going to jump up here since I didn't space myself too well. I'll get 16y over ty is equal to 160. I can cancel out my y's. I can cross multiply my t. I'll get that 16 is equal to 160t. I can divide both sides by 160, and this will give me that 0.1 is equal to t. That will give us our correct answer. The table summarizes the distribution of age and assigned group for participants in a study. Sometimes these tables are a little bit messed up when they post them, so hopefully this one kind of works out here. One of the participants will be selected at random. What is the probability of selecting a participant from group A given, so this is our condition in this conditional probability here, given that the participant is at least 10 years of age? So, okay, so I see these are all off a little bit. So this is 0 through 9, this is 10 through 19, this is 20 plus. So given that the participant is at least 10 years of age, I'm just going to be looking at these parts of the table here. So what is the probability of selecting a participant from group A? Well, group A is going to be our 18 plus our 22. Given that they're at least 10 years of age, that's going to be out of our 120. So this is going to give us 40 over 120, which is going to be equal to 1 over 3. All right, should be our nice, fun, tough one back here. The figure shown, point B in the center of each circle lie on AC. The ratio of AB to BC is 4 to 1. If the area of the small circle is 72, what is the area of the shaded region? So let's see if there's a more fun way to do this. But the simple way that we know we're going to kind of get this right is we could say, well, we could solve for the radius of the smaller circle by doing that 72 equals pi r squared. Then we could use that to solve out using the ratio for the whole big part, but there should be a nicer, faster way of doing this. So AB to BC is 4 to 1. So the radius relationship. Okay, so we can actually use scale factors to solve this in the most efficient way. So what we know is that these are going to essentially have, we're saying the ratio of the shapes is 4 to 1. So if we look at this, and this is kind of our nice, fun, tricky way of doing it, then I'll go back through kind of like our simpler math way. We could say that is equal to 4 and 1. So we could represent this as like essentially 4x plus 1x is equal to the entirety of like AC. Now, what this also means is, well, therefore, AC is going to be equal to 5x, and we know that AB is equal to 4x. So this is going to kind of give us a ratio between these two circles. And this is just going to be like for their radiuses. So the radius of AC to the radius of AB is going to be in a ratio of 5 to 4. Now, if we're looking for the ratio of the areas of the circles, since the formula for a circle area is pi r squared, that means we're going to have to square this kind of scaling factor to put it out to the area of the circles. So that means the ratio of the area of the circles is going to be the same as 25 to 16. This is going to tell us that the area of circle AC is going to be 25 to 16 as it is to the area of AB. So we can solve for the area of circle AC by using this. So we'll do 25 times 72. And then, so that's going to give us that 1800 is equal to 16 AC. Then we can divide 1800 by 16, and this will give us the area of the circle. So the area of the circle for AC is equal to 112.5. So our smaller circle is 72. Our bigger circle, the entirety of AC, is 112.5. So the shaded region is going to be the same as 112.5 minus 72, which will give us 40.5 as our correct answer. Now, I know this is like our super fancy way of doing it. As I said, the other way that you could do this, and we'll still 100% get the same right answer, is we could just go through and we could start. We'll still have to use that same kind of general ratio, but we could start with just doing pi r squared. So we could do 72 is equal to pi r squared. So we'll do 72 divided by pi, and then we'll take the square root of that. That's going to give us that the radius of AB is equal to 4.78. 73, I don't want to round this because this is probably going to get messy if we do. That means the diameter or the entirety of length AB, is equal to 9.746. And now we have to use that same ratio. Knowing that this is 4 and this is 1, the length of AC is 5 to 4 is it's relating to the length of AB. So we can do 5 over 4 equals x over 9.5746. So we'll multiply that by 5, divide that by 4. That will give us that the length of AC is equal to 11.96. And then we would have to divide that by 2. That's going to give us the radius of the bigger circle. So the radius for AC, I know this is a lot of stuff here, is equal to 5.9841. And then if we square that and we multiply that by pi, that gets us, we're just a teeny bit of rounding, so that would get us to like 112.49. We'll still be able to kind of work back to our same right answer, but the other method is kind of like your real technical scale factor way of working through. Now, I really hope this video has helped you out, and now we're going to talk about what you need to do if you want to get those really high SAT math scores. And the biggest mistake I see from students when they're self-studying is they just work through practice test after practice test after practice test, and they pretty much eventually always get stuck at some certain point for their score. And the issue with going through practice tests is you learn how to solve the specific problem you're missing, but you're not addressing your content deficiency or your lack of understanding of effective strategies for solving questions like those you're missing, and then you end up missing similar things in the future. So instead, what you want to do is use practice tests, but use them as a diagnostic tool for what you need to study and your progress, and then you really need to have an outside tool for filling in those content gaps and practicing with more of the types of questions you're struggling with. So what I have all of my students do is pick up a copy of my SAT math book. I genuinely believe this is the best math book out there. Every topic, every piece of content is covered, and I've spent tons of time making sure the questions are really reflective of what you're actually going to see on test day, and my students' results pretty much prove that this is an amazing resource. So as you're working through, strongly recommend using practice tests as the diagnostic and then going to the chapters in my math book or using my math course where I will teach you lessons and give you video explanations to everything for those areas you struggle with. Now, the other thing, which is really probably my secret sauce, which helps so many of my students score in the high 700s or get perfect 800s, is when we get to the last few weeks before test date, I have all of my students work through my advanced math course. This is 150 really challenging questions that I carefully picked for all of the types of questions and all of the patterns in solving questions that I've seen students struggle with over the years. And so you're going to work through these 150 questions as you close in on test date, and you're going to really fine-tune your math skills. It's going to let you identify if there's any content that you learned previously that you need to go back and review. But by test day, you're going to have this amazing playbook for all the different types of questions and how you have to solve them, because you get really in-depth explanations to everything. So you start learning the most effective and efficient ways of solving the problems, and that's really the secret to SAT math. You need to learn the easy, repeatable way of solving them. Then on test day, you can go in and just work through the questions quite easily, like you saw me do in this video.